now we're going to jump into our final presentation, and this from Sam Aaron, and I really appreciate Sam Aaron joining us. So Sam is the creator of Sonic Pi, and it's one of the largest live coding platforms that's out there. He's right down the street from me in Cambridge. And Sonic Pi is a free code-based music creation and performance tool that targets both education and professional musicians. And this talk is entitled Sonic Pi, Live Code Your Studio. Take it away, Sam.
Hello, can you hear me? Is it working?
Yep, all working.
Good, that's great. Pass one, okay. I've got no idea if any of this stuff is going to work, so just bear with me as I fiddle and press lots of buttons. Hi, I'm Sam. I've been introduced, so I don't need to say any more about that really. Shall I see if I can share my screen, see if that works?
Yes.
Now, which screen do I share? That's a good question. Now, where is it? Share screen. This one here. Share. And share sound. That might work as well. Okay. Does that work? Can you see that?
Yep, we can see that.
Yes. Cool. And also, I'm working Windows, which I haven't used since Windows XP. So if I don't know the shortcuts and things, then I'm sorry about that. And the reason why I'm using Windows is because you can get quite a powerful PC for much less than you can an equivalent Mac. And I've got a ton of Windows users, so I really should eat my own dog food. So I'm going to talk about today about this system called Sonic Pi. It's one of many, many, many audio programming languages that are out there. And it's one of those things where there's a ton of these things. Why would you bother creating another one? We can go back to the 50s with Max Matthews, as we saw before earlier. And since then, people have been reinventing the wheel and reinventing the wheel and reinventing the wheel. And so I've obviously decided it's a good idea to reinvent the wheel. Perhaps as a programmer, one of the things you do often to try and reinvent the wheel is to build your own editor. I've done that as well, which probably doesn't make much sense. But I get into the motivations of why I've reinvented the wheel and done something. Essentially, nothing I'm about to show you is new. Right? So we've just had two amazing talks that have showed you magical things. Magical low latency on low power devices, and magical speech, which just, I only heard the first part, but it blew me away by how realistic those voices were. And so I'm not going to show anything new. What I am going to show you is my attempt, the work I tend to do and have done over the years, is find interesting, specifically in this case, audio technologies, and find ways to make them more accessible. So to make them simpler and to lower the barrier to entry for other people who don't necessarily have that background or have the time it takes to ramp up the knowledge to get into the interesting places. So a lot of these systems here that you can see in this list on Wikipedia, they're really powerful, really interesting, but they will require quite a large degree of both either programming knowledge or music theory. And whilst they're great things, and I absolutely do not want to stop people exploring those sort of edges of those places and pushing them further, I think there's also a really interesting place to think about how you can actually take those ideas or aspects of them and bring them into a more sort of common, simple, usable system that lots of people can use. And what I'm going to, there's Sonic Pi down here, but actually the critical one I'm going to talk about to start off with is a system called SuperCollider. If you've never heard of SuperCollider, it's an amazing, powerful, open source synthesizer engine that's kind of like Maximus P, but instead of dragging boxes and lines, you write lines of code. And the nice thing about that is you can then use all the powers of programming languages, abstractions and functions to generate code, which generates your synthesizers, and to work with and interact with those synthesizers in really powerful and flexible ways. But the thing with the SuperCollider, although it's incredibly powerful and a fabulous tool, it is also like walking into a garage where your car is not assembled, but you have all of the bits, all of the nuts and bolts, and you have this huge Haynes manual that with like 10,000 pages on how to build your car. And of course, in that process, you can build whatever car you want, but you still have to build it. And this is really the way I perceive this system. It's a really powerful system, but you can't just make a sound. And you have to understand how to boot a server, whatever that is, and then you have to design a synthesizer, whatever that means, and then you've got to find a way to send it a message to trigger it to then to play your sound. You can't just walk up like one of these synthesizers, turn it on, press a note, and hear a sound. So although you have this huge flexibility and huge power, it comes at quite a high cost of complexity. So I really wanted to take this and put it into the hands of children. So everything I'm going to show you with my system, the Sonic Pi system here, has been designed to work with children aged around 10 and over. So although this might make things look really, really simple and often look really trivial, try to appreciate how hard it is to make complicated things simple. And whilst trying not to remove much of the sophisticated complexity of the system that you're working with. So Sonic Pi really is Super Collider with a very simple front end. So taking all the power of Super Collider and then masking it with a very simple system. And this is a simple system designed originally for education. So I worked within schools, and this was around the time when in the UK we had a new computer science curriculum, and this was the government saying we need to teach computer science, not just how to do spreadsheets, although actually they are really good computer science, but they were taught in the wrong way, or how to do logo design. And we had to teach algorithms and data structures and all that good stuff. And when they went and asked people who are experts in programming what got them excited, well, typically they were old white guys with beards, and they would say things like sorting algorithms or binary arithmetic, which perhaps may have excited them, and if we're trying to find more programmers that are like them, may also excite them, and maybe excite many of you if you're of that ilk. But I think if we're trying to diversify and broaden the participation in these areas, I think we need to find ways which are interesting to a larger set of people. And so I think music is a fabulous tool for engaging people across all genders, all cultures, all backgrounds. We all have an interest in music, and we have a very wide variety of interests and different musical styles. But music certainly is a very powerful common language which binds us all. And so my thought was, can we take the work I've been working for a number of years. I actually worked on a system called Overtone. So that's actually the Overtone. Well, it isn't even popular. It's no longer that used anymore. So github.com/overtone/overtone. So this was a previous system I was working on, which has the same ideas. It takes Super Collider and puts a language on front of it and makes it programmable. But this was also trying to be a very powerful, complex thing, and this really wasn't something anybody could easily use. And I'd have a number of issues. Like, so I would perform at festivals. So here's let's try and find a picture. Here's me performing at a festival. It looks like a standard person doing standard electronic music. Not very exciting. What's going on? But the cool thing about when you're performing with code is that you get to project the code on the screen to the users, well, these in this case are the audience, and you can also make that code readable. And then in the early days, when I was using the Overtone system, people could see the code, but they had no idea what it meant. And I'd often actually got a really interesting review in a magazine for one of my performances, which said, great sounds and great visuals. So that's kind of like saying to Jimi Hendrix, great sounds and great wooden medallion. If you've never seen a guitar before, you're not going to understand what on earth that wooden object is around Jimmy's neck. And so you're just going to write about it as some kind of artistic artifact or jewellery or some sort of interesting wooden object that maybe has some interaction with the sound or maybe doesn't. And in the case of code, most people haven't seen the real code, and those that haven't really seen it used for making music in this way. It's still a very niche thing. And so that was a real problem for me, because I actually decided it wasn't just interesting to be able to make music with code. I wanted to be able to let other people do the same too. So this Overtone system is a really powerful thing, just like Super Collider. In fact, it is Super Collider with a different language. This is a Lisp language called Clojure on the front. But it had many of the same problems. It's very difficult to install, very difficult to use, very difficult to learn. But if you do learn it, you can do amazing things. So Sonic Pi was an attempt to try and simplify all this. And I was working at the University of Cambridge in the computer laboratory, and there was a small bit of money going around and I was about to leave as well. My contract had expired, so I was about to go back to being an industry programmer. Saying, is anyone interested in building something that might engage children in programming? So I was like, I could take my overtone ideas and perhaps build a very simple system. So Sonic Pi is that. And it was originally specifically just to teach computer science and just to be a very simple tool to allow people to explore the basics of computer science. So that's where the education part comes in. But since then, I've made many discoveries about these kinds of systems, which have both surprised me and excited me. And so I've been taking the system not just towards education, but also towards performance and towards professional musicians as much as I possibly can. And I think that's a really interesting space to be in, because if you look at a lot of education systems, they typically are very simple. So they are trying to make it really low barrier to entry, really accessible, really easy to do the projects that were created with it. But once you've done those things, there's not much more you can do. There's like a kind of glass ceiling that limits your expressivity and your creativity. And this isn't the case with a piano. You know, it's super easy to pick up a piano. Well, you can't pick up a piano, but you can go to a piano and you can play the notes of a piano. And if you've never seen a piano before, anybody can teach you how to play all the notes of a piano really easily. And the same with the guitar. Anyone can teach you how to play all the strings of a guitar. So the accessibility of these instruments is really, really low. And the same with the synthesizer. You can play with the knobs and make some sounds. But the reason why I think people pick up a guitar and actually spend time practicing it, and same with a piano or a synthesizer, is that there are people who do amazing things with these instruments, that are virtuosic, that become the role models. And they provide a demonstration of the potential of these instruments. So when you see somebody doing an amazing Tchaikovsky performance, or someone doing crazy synthesizer manipulations on a Eurorack or something, you think, wow, I want to be able to do that myself, and that's perhaps provides you that motivation. And so I wanted the educational system to have that aspect as well. So it wasn't just simple to get started and easy for schools, but could a professional musician use this? And if they could, what could they do with it? Because if you can get role models using code systems to make music, I think that's going to really change the perception in society of what code is, and get a lot more people engaged, and hopefully start to change this really unfortunate perception that code is something just for businesses, for making money and for making business applications. Just like the English language, or any written language, is not just a language for legal documents. You know, it's something that you can use to express yourself in many powerful ways. So this is what Sonic Pi was. It was developed for a classroom, but some talks about it, and there's a book. But you can take these simple pieces of code and you can generate interesting sounds. So these are on the website just as a thing to press and to hear. But I'll show you the actual real code in a second. Do a bunch of stuff with it. It's available. It's already installed, pre-installed on the Raspberry Pi. It comes for Windows as well, and also for Mac. So just download it and get started. And so that was also a critical thing, is that a lot of these systems can be quite complex to install. And so if you go into a school, you don't have any opportunity to do anything complex, because the teacher will just want it to work. So it needed to just have a very simple install. You just double click and you install. And so when you do that, I wonder if this is going to work. It opens up with an environment like this. Is that visible? Can you see that? Hope so. So this is the system here, and it needs to be really simple. You just type in code like this, and then you press the run button and you get a mistake. And this is a very standard thing to be in. Now, what I think is quite interesting, especially on the back of the previous two talks, is that where I'm coming from is a high level interaction, the sort of the interface for musical systems. And I'm making all these claims that this is all really simple and easy and not hard at all. But I'm showing you code, right? I'm showing you like load example, showing you code like this, and that's obviously looks really quite scary and daunting. So I'm trying to make a sell really that this actually isn't hard. And I think that's hard sell, because most people won't believe me. But if I were to show you, if I were to get the website, where is my web browser? If I were to put some classical music score on the screen and then show some images of that, yeah, look at this. This, for many people, is seen as simple, but actually this is a very sophisticated, complex notation with concurrency and with all sorts of metadata and all sorts of... Oh, actually, this is a ridiculous version, isn't it? I'm giving you a stupid version. But in general, music notation is impenetrable to the majority of people. But for musicians, it's really obvious and simple. And what I'm trying to say is actually there's no difference between these two things. They can represent audio events, and they can represent manipulations of those. And in fact, in many ways, this approach has a lot more flexibility than this approach. This approach is designed specifically for easy reading of a human, typically a single instrument with a single voice, or maybe two hands on a piano, but you rarely see people playing 3 lines at the same time. And so designed for sight reading and designed for communicating that information with a high degree of interpretation as well. Whereas this actually can do a lot more. You can not just store notes through time, but you can also store studio effects and randomization and abstractions, and I'll show you a bunch of these stuff. But yeah, I can listen. Hopefully within the next 10 minutes I'm going to try and through how you can get from nothing to that. That's really the critical goal. So one of the nice things about code is that you can start with a blank page and it's really simple, and only when your musical needs increase do the amount of words you need to write increase. So unlike a synthesizer like this, you immediately see the full complexity of the interface, and you're faced with that, and you have to deal with that immediately. And that's really, really obvious with a Eurorack module, where you have a ton of modules and tons of knobs and wires and all sorts of stuff going on. And so that interface is there, it's immediate, it's accessible, it's fun, you can play with it, but it is complicated and complex. Whereas here, we can actually choose the level of complexity by choosing the amount of words you write. And the simplest word to write is just to trigger a sample. So here are a bunch of built-in WAV files, actually they're FLAC files, like this lunar land sound. I can trigger these things. If I wanted to change the level of amplitude, I just add another word, just amp. I can change the rate it's played back at. So I can add these things. Notice here though, every time I press the window key, it doesn't stop when it's going, it creates another musical performer to run that specific code. And if anything else is running the same time, it just layers it on top. So in programming concurrency, there's multiple things happening. And what I found really interesting in education and programming is that this is seen as a very complicated thing. But in music, concurrency is extremely natural. Like, it's much more natural to have a band of 3 people, one singing, one playing bass, and one playing drums, than it is to have the same person doing all of those roles concurrently, like trying to do the one-person band. So these where you cross over these boundaries, you actually find that some things are easier in one domain and seen as complicated in the other. We can also do things like change the rate to be backwards. And actually, if I get a mistake, you can see the error there. It's going to come in. It's coming.
Just another quick thing, Sam. While you're doing that, when you're doing something with the sound, we can't hear you over the sound.
Interesting. Okay, so maybe what I need to do is turn my microphone off. Let's give a test. If I turn my microphone off Zoom.
Yeah, so just to clarify, when we can hear the sound fine, but we just can't hear you when you're talking over the sound while the sound is playing. That's all.
Can you hear me now?
I can hear you now. Yeah, we can hear you fine. It's just when the sound is actually playing.
So it shouldn't have an issue with the playing. It should merge the sounds together now. So the sound was going through Zoom. Now the sound is going through here.
I see. Great.
Let's see. And I can actually, is that loud enough? I can actually turn myself up.
Yeah.
Or I can add like some reverb to my sound and make me all roomy like this. Is that better?
That's great.
Or some echo. I can echo around. Is that easy to understand?
Not with the echo, but yeah, we can understand you.
What's fun here is that you can actually see already I can take a live input. Like that could be a guitar, that could be an electric violin, it could be a synthesizer, and I can immediately add and manipulate that sound live, and I can be mixing those and adding those effects whilst the audio is being played. So it magically just swaps these things out. Now, that's all the magic of SuperCollider doing that in the background. Sonic Pi just controls and configures it and tells it what to do in the right way. So that's a lot of fun. So let's go back to these samples here. So I can play this, like, you can also play like drum loops. So like we got our old friend, the we're going for a loop. Amen. Coming through, maybe a little louder. Yeah, is that good? Can you hear that? So what people tend to want to do with these kinds of things is to be able to loop them. So let's loop that, and let's sleep for some time. Kind of working, but we have that pause in between. So we can start to see now how this sort of algorithm of a loop works quite nicely with a looping WAV file. What we're missing here is the right time to wait before we spin around the loop. So one. So now we have nice. Great.
Oh, when you stop it, we can't hear you. No.
Oh, yes. Yes, this is an issue now. So if I stop here, okay, I need to keep the code running. Okay, can you hear me now? Yeah, you need to butt in, right? So this is live. Oh, we're good. So the kids would do this. Would also do this, right? So they do like sample, bass drum, house, seat for half a beat, and amplitude, say 10. And we've got that. We've got the kick drum going, and so they would want to do the two at the same time. So what they would do is this, right? And where's the kick drum? So this is an interesting sort of computational problem. If you were doing an interview, this would be a question: why can't we hear the kick drum? And the real reason, is that the computer will enter this first loop and stay there forever, and never ever get down to this loop. That's completely natural. Loops are like black holes that take the program and keep it there forever. So this is an interesting problem because in the education context, the teachers would say, well, that's it. Well, we're not going to teach concurrency. We can't teach two loops at the same time. It's not on the curriculum, But the kids all wanted to play the drums at the same time as the bass, or the kick drum at the same time as the arm end break. So Sonic Pi has this nice trick called the live loop. And the live loop needs to have a name, so let's call this drums, and this one called bass. So you just give them names. And when you run them, I've got to stop at the top there. They play at the same time, which is really nice. So we've got this loop playing at the same time as this loop. Now this, in a DAW, these are just two lines going across, right? That's a very simple thing to do. What you can't so easily do in a DAW is do things like change this so it's a different time signature, and then bring it back in, stop this one once it's going, sync it with drums and have it come back in time, like whilst it's all playing. These are all things you can do whilst you're working with live code. And what else? Also, you can do all the things you do forward to that, echoes, to the drums, pick it up. Or I can think for a very short amount of time and only play first. So what it's doing here is it's just doing automatic onset detection sample and playing with the 7 energy. But I can use randomization. So a low pass filter on the kick drum. And then where the fun really starts is when I can do things like this. So I reset what's called a random seed. That sort of resets all the randomization systems. It will then pick 7 random onsets in the online break and then repeat. But it will reset it the same way every time to get this repetition. And so now I can change my breaks by putting some random number here. play that. Here I'm using, again, this is sort of more tricky the door. I'm not using sort of 8, 16, 32. I'm using unusual numbers here, so you get this really interesting polyrhythmic stuff. Very, very useful. Of course, I could just bring it into 8 and then have it be a bit more of a, you might want to have to do. And then also we can start to pick these things up, so I can put like guitar sample in, take that off. Oh, and now it's not actually recognising that at all. Right, so you can switch these samples on the fly. It automatically loads up the memory for you from these. See, all over here. Some reverb around the whole thing. So what we're doing here is we have multiple loops which are looping round. They don't have to be in sync. They can be out of sync. They have their own tempo. They have their own BPM. They have their own sense of time. And you can have as many of these live loops as you want. They just have to have different names, and you can work with them in different ways. And what we're doing here is triggering built-in samples. And that's using, where are we going here? This synthesizer. So this is a can I zoom in on this? No. This is just a Maximus P-like rendering of the sampler system, and this is in Super Collider world. And so every time you see the word sample and this kind of thing, it's creating one of these in memory and using it to trigger that sample back. So you're having multiple of them at the same time. So one of the different approaches of using of this approach is that every time you create a synthesizer or you trigger a synthesizer, you're actually creating a whole new synthesizer, not playing 2 notes in the same, but it's like if I were to play a chord on the piano, I'd play 3 notes on the piano. But with this approach, I'd have 3 separate pianos and play a single note on each. And that gives you different affordances and a different approach. And so what do I mean by synthesizer? Well, in Sonic Pi, you've also got the ability just to trigger basic internal synthesizers. So if I play note 80, let's get a beep. And note 86, or 50, a bit louder, like this. I can change the release time. The release by default is 1, so everything has a default. Or I can reduce it, make it longer. And I can do the same kind of tricks here. I can put this in a live loop, I can sleep for a short amount of time, and I can play lots of these. Or I can use a data structure like a scale. I can use typical Western numbering mechanism, and I can say like what kind of scale. Minor pentatonic always sounds good, and choose one of those. Yeah. Now, can you hear me? Yes, you can still hear me. That's good. And so there's a whole bunch of these built-in synthesizers, which are nothing more than Super Collider synth defs. And if you know Super Collider, you can design your own one of these, and you can import it into Sonic Pi, and you can use it to trigger, to work with in that high-level language I'm showing you just now. So you're not limited to the synthesizers built into Sonic Pi. You can extend them and work with your own. Same with samples. These ones are all built into the system. They're all free Creative Commons Zero license samples that I got from freesound.org, just for workshops and for school lessons, just to get started. But you can totally just use your own now. This is Windows. This is going to work. It's going to work. It's going to work. I have a folder here somewhere on Windows. I don't actually know on Windows how to get to my home folder. So I always go to see users. So this is obviously me not knowing what I'm doing at all. I've got a folder called Node and a folder called Samples, and in here I've got like some WAV files, And here is a nice WAV file. Here I can just take that WAV file, drag it into Sonic Pi and drop it. And you can see here, actually, let's just put it where it was, where the cursor was. I can just pop that there. I can delete all of this and just type sample in front of this and put amplitude 5. And it will play me that sample that's on my file system. So any WAV, FLAC, AF, OGG file, I can play with this approach. I can slice it up. I can play half speed, full speed, backwards, and work with it in different ways. And what a nice thing is that I can actually just give this a name. So I can say like samps equals this long thing, and I can actually not. This is like a full path to the WAV file. I can actually delete the file here and specify the name of the folder. So I can have like a whole folder of samples which are related, and I can play that. I can play samps. Maybe it's not loud enough, but let's go for amp 10. I don't know if I was trying to amplify the folder there. And so what we got there is the ability to play a folder. What on earth does that mean? So what happens here is that Sonic Pi sees that you've actually asked it to play a folder, and it will then find all the playable audio files, sort them alphabetically, and play the first one. And then I can then index through that, so I can actually say, play me the second sample in there. And I can index through. Or I can even search for samples that contain search strings. So I have can you still hear me? Yes. So I've said actually, when I do a performance, I have like a bunch of these folders with audio files, and just give them nice little shortcut names, so I can remember those rather than remember all this nonsense. So when I'm performing, I can just say sample Mars Acid 7 amplitude 10. Get like a nice TP303 sample played. And which also means I can do the same kind of trick as before. I can put this in a live loop, sleep a short amount of time, and do onset pick. Now choosing random samples and lots of them to play at So you get the idea there, right? I don't want to spend too long doing that. But all I'm doing there is manipulating very simple things. And I'm going through this incredibly quickly. How long have I got left, Josh? Is it like 5 minutes, 2 minutes, minus 5 minutes?
How long would you like?
Well, I mean, as long as people don't get bored. Like another 5 minutes would be fine.
Yeah, that sounds great.
So all I'm really showing you is like a range of things which are really fun to do and very easy to do. And so far as triggering internal synthesizers, adding effects is really easy. Working with external synthesizers with, external audio feeds. Using basic algorithms and data structures to manipulate them, and that's nothing more than a loop or repetition do this 7 times, then reset. Do it 7 times, then reset. This one's just playing a very simple audio loop file from a sample pack that I bought, stretching it to 8 beats, and then spinning it around. What's nice is that time is all inherited, so I can use underscore BPM and change it. So by default it's 60 BPM, so that sleep for 1 is sleep for 1 second, so it's easy to teach in schools. But I can actually put it to be much slower.
Oh, we can't hear you, Sam.
If that's something that's interesting to you. So those loops do not have to have the same BPM. So unlike a standard DAW, where you say this whole track's in 120, 130, here you can actually do all sorts of crazy stuff. So things like, for example, Steve Reich's piano phase. That's just a really simple thing in Sonic Pi. You just describe the notes you want to play. In this case, here's my list of notes. And I have 2 live loops, and they're both sleeping at different times. Now I've just got rid of the code to do my microphone. So when I run this, it's not going to hear my voice. So I'm going to copy it. I'm going to undo this. I'm going to then paste it back here. Haha, tricky. And then delete all this other stuff down here. So now we can hear hopefully both of me. And you can hear now there's both live loops playing at the same time, but they'll soon go out of phase. So this kind of stuff, it becomes much more possible and easy. This is obviously very tricky to play, very hard to notate with traditional notation, but with code it becomes much easier. And then what's also really fun is that you can plug in like traditional like synthesizers. Here's like a nice little Moog synthesizer, and if the MIDI's plugged in, if I turn the knobs, I don't know if you can see at the bottom right here, you can see here that it's actually immediately seeing those MIDI events coming in. So I don't have to write a single line of code. Like, it doesn't need to be anything in here. This can be blank. Although if I delete my line of code, which says live audio, it's gonna, yeah. Then it still is able to receive and to be able to see these things. So any MIDI event, any MIDI device will automatically be sent in, and I can easily write some code which syncs with any of these events that are coming in. So here's my control messages. And I can then do something like play E3 release time short. So now it's playing E3 every time it sees a MIDI note. I can actually get the note and the velocity from the MIDI device, and I can play that note. Maybe I need to make it higher. Oh no! This control message, so the second one is the actual pitch. The first is the control device knob number. So now I'm controlling that really easily with this. And then finally, every time I've done the word play, like something like 70, and I don't know, let's just quickly just do that like this, play 5, short time. Can we? Was it doing anything? No. Play. There we are. This is triggering the internal synthesizer, which I've shown you can change by changing the use synth command here. To like, no, that's just going to be horrible sound. Blade. But I can also put MIDI here. Right now, on my Moog device, as you can see here, like the light's flashing to say it's getting MIDI messages. So I can actually then use the live audio mechanism we've seen before to pull in the Moog that's on input 3 in this case. Oh no, it's on input 2, amp 10, syntax error. Can we see what's going on? There. let's just do octs. E, 2, 3, tick. Now, if you can hear that, hopefully you can hear that. So what I'm doing here, so what I was doing there was triggering both the Moog synthesizer and also bringing the audio in, and I can actually show this. Add effects like crush it. Take the effect off. So you can very easily work with external synthesizers, trigger them, bring the audio back in. This could be your DAW you're sending these events to. You can use a randomization system to the DAW could just receive those MIDI numbers and just display them. Then you can use your DAW's fancy MIDI techniques and synthesizer techniques to actually render those audio things, or you can work with audio and bring it back in. Really, you can do all sorts of amazing things. And I think that although I particularly use it for performance and also for teaching children how to code, I think there's lots of ways to use this in your studio just to render an interesting little bit of audio, or to manipulate that knob in an interesting way, and to send it back out again. So you can receive a MIDI message, you can maybe add an octave to it, or put a random number of pitches to it, or whatever you really want to do, and then send it back out as another MIDI event to maybe multiple MIDI devices, or a different MIDI device, so you can route MIDI really effectively. And then finally, everything you can do with MIDI, you can also use OSC. So you can use this thing called Open Sound Control to send events over the network to VJ tools, to synthesizers which can speak OSC, which is still a smaller number but are growing, and that way you're remove yourself from the confines of the limitations of MIDI, which are being addressed with this MIDI 2 stuff, but that's still yet to be really adopted by the industry. So when I'm doing performances, I'll be generating internal sounds, I'll be triggering these external sounds, and I'll also be triggering my VJ tools, all from the same piece of code, all in time with each other, all super accurately timed. So that's all go. So live coding languages are fun. There's a whole ton of them. This one specifically is for trying its best to make things as simple as possible, and that means simple enough to teach at schools, but it also means that when you're giving a performance, that the audience should be able to read some of the code. So when I give my performances, I tend to have really simple, large text, so the audience can have some kind of a way in to try and read and understand what's going on. And hopefully, if people have even played with Sonic Pi, then they'll actually have a more deeper understanding. In the same way, if you've held and touched a guitar, you're going to appreciate a guitar performance better than if you've never touched one before. So hopefully by making it easy to get started and to play with, then when people go and see these kinds of live coded performances, then they'll be able to understand a lot more. So when you download it, it comes with a tutorial, which is basically a full book which will teach you everything you need to know. If you don't know anything about programming, then it'll teach you that. If you don't know anything about music, it'll teach you the parts of that you need to get started. So you can read through all of this, full tutorial. There's a bunch of examples with code you can just run and play with. It's got a description of all the different synthesizers which are built in. It's got all the effects which are built in. There's the built-in samples, but really you're much better off playing with your own. And then for every different part of the command of the language, there's descriptions and examples of how to use it. So it's fully documented to the best of my ability in multiple languages. And so if you're an audio engineer out there who knows SuperCollider or is interested in synthesis design and would like to learn SuperCollider, then really if you want to help out, you can design new sounds, and if you're happy to open source them, then I can push them to the audience of people using the system. And also, if you're in the studio and you have a play with this, you think, wow, Sam said it was really easy and it isn't, or Sam said it could do this and it can't, or I wish it did that, then let me know, and I'm really looking to try to improve it to make it a better tool for everybody. So some features you'll ask for will be hard to implement, some will be actually really easy, and so if I don't know what you want, then it's going to be hard for me to actually build it. So I'm really looking for feedback and looking for people to play with it and to let me know how it works. And I'm really looking, especially, although I've really focused initially on the education sector, music. So people with actual studios who are and people who have got musical knowledge and synthesis knowledge to play with it and really give me their feedback and complain where it needs to be complained about. And I really do my best to make it as a decent tool for everybody to play with. That then may become a bridging jump out to other live coding tools or to other crazy things. Or many people have actually started their programming journey by playing with Sonic Pi, which is quite fun to read about and to meet those people. So there you go. That's a very quick whirl through Sonic Pi. It's a tool for education and hopefully for your studios. Please let me know how it goes, and I'm available on the internet. Hi.
Wow. Thank you very much, Sam, for your time and for that incredible presentation. We have quite a few questions. I have
Brilliant,
a
brilliant.
so I have a question. How many people do you know how many people worldwide are using Sonic Pi at the moment, or how many times it's been downloaded?
I know. All I know is that the number. I see the number of downloads and a number of people who are checking for updates, and I've seen over 1.6 million people have checked for updates. So
Wow.
I'm sure the majority of them are not regular users. Um,
Mm,
we have a nice forum which has thousands of members, so that's kind of like probably the size of the actual active community, which is free to get along with. But yeah, it's still a very niche thing, and it's growing, but slowly. Yeah.
great. And have you seen any sort of trends in terms of regions that are really active with Sonic Pi
Yeah, I mean,
more than any
in
other?
Japan, I mean, all I can do is like watch Twitter and see who's mentioning. So I search for the Sonic Pi on Twitter and see who's talking about it. And there's a ton of Japanese people doing some really cool stuff in these VR spaces where they've got made these sort of VR nightclubs with huge walls of screens, all with all code, all dancing around, and their avatars dancing. So yeah, the Japanese seem to really like it, and we have a really good Japanese translation of the tutorial, which is really helping that community. And actually, we're crowdsourcing the translation, so we're translated to many languages already, to varying degrees of completion. So if you are not a native English speaker and you would like to help translate them, please get in touch, and I'll show you how to get started. You can do it one sentence at a time.
Fantastic. We have a question from Florian. He would like to know, we saw that you can do different scales, but are you able to do equal temperamented or unequally temperamented scales like
Oh,
12J?
sure. Right. So, yeah. This is a MIDI note, right? So this is like a standard tuning system, a Western tuning system, where you take some starting point, 440 hertz, you give it a name, and then you can double that frequency. That's the only thing across all cultures, which seems to be musically shared. And then you divide that by some number of spaces, typically 12 in Western notation, and then you give the frequencies for each of those. And so that's what this is doing here when I'm doing these integers. I'm going up on the chromatic scale in Western tuning. But I could put floating point values here, so I have access to the full spectrum of all the pitches. But if I want to work with different tuning systems precisely, I can use tuning, and I have access to a few different built-in tuning systems that we can work with. So these will actually figure out those frequencies for you. So you can either do it yourself manually by just putting the actual specific frequency you want. So drone music, for example, is really easy. I can just play 70 and play 70 point, make them really long envelopes and have nice, interesting out of phase synthesis. So you're not limited to working with the notes for piano. You can work with any frequency you want. Does that answer your
Nice.
question?
Yes, yes. And of course, Sonic Pi seems to be geared towards kind of dance music. Has there been any work into other types of music that may not be evenly kind of temperamented, like orchestral jazz music, rock music? I know that there are significant challenges to being able to do something like that in a live coding environment. Have you given any thought to anything
Yeah, I
like that?
mean, so the focus of dance music, I think, really is just a relationship with the affordances that loops offer. Like dance music is really about loops and loop structures, and they're really easy to do in code. So I think that's just really, it's just more natural to do dance music because the algorithms are there. But this same for the sleep, right? The sleep 1 here. I can play note 70, then sleep for 1, and then play note 70.1. This can be some fraction of a time, very accurately described. I now have the ability to play any melody that you've ever heard in your life and ever will hear by choosing which notes to play and when to play them. So I'm not limited to dance music. I can make any kind of music because I can precisely choose the timings and the pitches. And then I can also design my own data structures and algorithms to work with those kinds of things. So there's a whole ton of different things. There's a lady in Canada that I read on Twitter that she'd made an opera with Sonic Pi. There was a guy in Turkey who had started to add Turkish scales to Sonic Pi to work with his and work with traditional instrumentalists and with code as well. So although dance music is easy to do because it's just a loop and you can just get a WAV file with a drum beat and you can play them together like I did before, that's just because that's really the reason why I showed you it's because it's super simple to do loop, sleep 0.5, kick drum. But
right.
you really are not you're not limited at all. You can have a single composition like this of whatever accurate plays and sleeps you want to describe your composition. So this is much more accurate than Western notation, where you're giving the BPM, the tempo, and you're describing things in quavers and semi-quavers and crotchets and whatever. Here you really are able to precisely choose the pitch and the timings, but also you're able to do concurrency. You're able to describe multiple things at the same time, and you don't have to do the loops at all. You can just do, I can say, in a thread, play this, and in another thread, here's another composition. So these will actually play at the same time. So whatever code I put in here will play at the same time. So I can very precisely describe a single sequence of music and an additional sequence of music and then play them at the same time. And as many as I want and start them however I want. So I really don't think it's limited to any specific genre. It's just a matter of people taking their musical knowledge and applying it to this.
Great. There were a couple questions in terms of the syntax of Super Collider versus Sonic Pi. Or is Super Collider syntax similar to Sonic Pi? My understanding is that Sonic Pi is meant to simplify the syntax that you would normally have in Super Collider. Is that
About programming languages now, and so if what I say is not obvious, then I'm sorry about that. And please ask either more questions here or offline. Sonic Pi is built on a professional used, commercial used programming language called Ruby. It's an open source language. And the reason why I built it in Ruby is because I used to be a professional Ruby programmer and I had 2 weeks to build the first version. So I was like, need to do it quickly. And Ruby gives me a lot of nice syntactic elements like this do-end stuff. Allows me to describe a context of code. So I could say, for this context, repeat, or for this context, add reverb, or for this context, run it at the same time as this context. So this is a part of a language you don't find in many other programming languages. In this sort of simplified term, you can do everything in every programming language. It's just about how many words you need to write to do that. Mm-hmm. SuperCollider has its own language, the SuperCollider language, which is actually based on on the same sort of foundational ancestry as Ruby. So they actually have a very similar common history, and so they end up being quite similar languages. So from a language perspective, there's not that much difference. Actually, they're quite similar. The reason why I did it in Ruby is because it needed to be a commercial language so that schools would accept it. So if I said, "Hey, I built this esoteric language," the head teacher would say, "Well, why is it not Python?" Mm-hmm. And I'd have to have a good reason for why it's not Python, and they would just say, "No, we're not teaching it." So Ruby, I could say, Twitter was built in Ruby. It's obviously not anymore. The UK government does all its open source work in Ruby, and if you go to San Francisco, you get paid the most as a Ruby programmer, which were true at the time. And they were like, the head teacher go, "Oh, great." So none of these have to be real reasons. They just have to be just to pass what I would call the head teacher test. But then I think you need to look beyond the language. So the language is one part, but actually what I'm showing here, this in thread, is implemented in I've built it on top of Ruby. And live audio, I built it on top of Ruby. Mm-hmm. And the live loop, I've built it on top of Ruby. So these are abstractions that you could totally build in SuperCollider if you wanted to, and they have similar ones. But I've built them to make it really easy to do the kind of things that I want people to be able to do. And so it's both the language and the abstractions on top, I think, which are interesting. And in many ways, this language is much closer idiomatically to something called Erlang, which is an amazing a language for telecommunication systems, so for phone switching networks and for high concurrency, than it is to either Ruby or SuperCollider. And actually, I'm much more interested in taking things in that direction, where you have lots of what we call threads or musicians playing at the same time in a very accurate way.
And is there a plan to have some sort of Sonic Pi that is able to run in the browser, like a web audio implementation?
So that's an excellent question. So Sonic Pi really relies on SuperCollider for all its audio synthesis. So if someone were to port Sonic SuperCollider to using the fancy web tools that you can have now, these what's it called now? I can't remember off the top of my head. But you can obviously compile things down, C down into JavaScript, WebAssembly. Then that would be great. But no. So I think and also Ruby doesn't work in the browser either. There are Ruby-like languages in the browser, but again, you'd have to really implement it all from scratch. So you could totally build something like this with a web audio backend, with a language that looks similar to this, but it would be a new GUI. But this GUI is written in C++ and Qt, and so I'm using SuperCollider and I'm using Ruby. None of those technologies would just directly port to the web. So it would be a from scratch rewrite.
Okay. And is Sonic Pi able to display a signal flow graph for synthesis algorithms, or is it strictly command line?
So a signal flow graph. What do you mean by
Yeah,
that?
so something I'm thinking something like Max MSP, where you have objects and you're able to patch them into each other, or is it?
Like a data flow language.
Yeah,
Yeah. No, it's not. So that's the data flow part is really about the synthesis, how the audio is generated. And that's really all in SuperCollider land.
sure.
Um, the Sonic Pi really is about when to trigger things and how to trigger things, and then on a high level, a declarative description of what has what effects and what's played at the same time as other things. And that doesn't really lend itself to a data flow paradigm at all.
Okay,
So yeah, I think that I think that I mean that you're kind of describing this kind of thing, yeah.
that's right.
And this is the audio pathway. So these dark things are the control points. These are the knobs. The white things are the control rate stuff, and the grey things are the audio rate stuff. But this, to me, I haven't yet really. So with Sonic Pi, it's really easy to come up with lots of ideas about how to extend it and how to make it better. But I have to sort of make it go past a number of filters. The first is, can I imagine implementing it? Usually the answer is yes, but how long will it take? And then the next thing is, does it fit with all the other abstractions inside Sonic Pi? That's a bit of thinking gets past that. And then the final test is, could I teach it to a 10-year-old child? This I can't teach to a 10-year-old child yet. It's too hard. So no, it doesn't go in. So I have to rethink. So there's a lot of cool ideas, music theory and audio engineering concepts and techniques, which really could make Sonic Pi much more interesting. But I haven't yet found a way to simplify them enough to make them what I would call 10-year-old ready. And the reason why I started off with that philosophy is obviously because I was working in schools, and I still do. Sonic Pi is used all in schools all over the world to teach computer science, and that's to me a really important starting point. But also, I discovered that a lot of the ideas and thoughts and techniques I implemented to make it easier to teach and easier to debug with a classroom with a teacher who can't program, because a lot of these computer science teachers haven't got a background in programming. They're just teaching it and they're interested and they want to do it, but they don't really have that. It's not like a physics teacher typically has a physics degree. Many computer science teachers don't have a computer science degree. So you have to make these things really simple to work with. So I put a lot of effort into making that possible, and also to deal with errors like you can't tell a child not to press the button. They will press the button 10 times in a row. So you've got to build a system to be able to be tolerant to all those things. And so I discovered that a lot of the implementations and ideas are built to tackle that situation in the classroom turn out to be perfect when I've had far too many beers and I'm in a nightclub and it's 3 a.m. My brain's not working at full capacity, and I've got a massive audience in front of me expecting it not to break. Or if it does break, they want me to fix it immediately. And so actually making things simple enough for a 10-year-old child turned out to actually improve the fun, the fluidity, the flow status of the system in ways I hadn't even imagined before. So that's something I really I'm very precious about and want to. There are lots of other live coding languages and systems out there. Supercloud is one I mentioned before. There's tons of others which are exploring that complexity end of the spectrum, and that's great. They should definitely do that. Sonic Pi is trying to figure out how do we make it simple enough that you don't need to use all your brain power on. Because I would rather use my brain power not on fighting the system, but on thinking about where I'm going to go next musically.
And what do you do outside of Sonic Pi? Is this what you do full time?
Yeah, for the last over 7 years, it's been pretty much my full time job. So I got funding originally whilst I was working at university. That funding dried up, and then since then I've been finding ways to fund myself. So now I have my own company, which essentially is just a financial vehicle for paying me, and money that goes into there goes either from donations from people via Patreon, which is about half of the income, and the other half is when I give performances and talks and workshops. I charge money for those, and so then I say if a conference wants me to perform in their conference party, I say, can you pay me please? And then they say, why? We don't normally speakers don't normally charge. I say, well, because my product is free, and you're essentially paying for me to develop it further and maintain it for everybody else. So that seems to have worked out really well. Obviously now with this virus situation, all my gigs have all just evaporated. But I've recently moved on to doing streaming. So I've got the setup now where I can stream. I got a really decent fiber connection. So last week I performed to over 9,000 people for GitHub, which is a big open source developer tool for sharing source code. There's other things I'm planning as well at the moment, which are even larger, which is pretty crazy. So I think actually, interestingly, this new live streaming world we find ourselves immediately in is really suited to what I'm doing. So I'm really able to take advantage of that.
Amazing.
It's great.
And we have one more question, which is, are you able to freeze? So do you run into any CPU load problems? And if you do, are you able to freeze any of the loops or any of the parts the way that you're able to do in a DAW?
Like so, no. The answer is no. I haven't made that as part of the workflow. Of course, you can take any of the audio aspect and record it to a WAV file to disk, and then bring it back in as a sample, as I shown before.
Yeah.
And in fact, actually, there is. I say that there is a technique I've implemented, which is not yet 10-year-old ready, but it's there, which allows you to record any audio of any part of the system as a stereo buffer internally in memory, and then play it back as a sample. So I do that with a guitarist friend where I can build looper pedals really, really easily. So I can take any audio he's sending and then store it internally as a memory, as a WAV file in memory, and then work with that. So yes, actually the answer is yes. It's just I haven't got syntax to make that super simple yet.
Okay, great.
Yeah.
Well, that's it for the questions. Thank you once again,
you.
Sam, for all your time. Really, really amazing. First time I've ever seen live coding, really, and yeah.
Cool. I mean, it's really important to emphasize there's a whole bunch of other live coding systems. This is one of many. It's the only one I'm really aware of, which is focusing on making things simple. And if that's your bag, that's great. But there's a lot of people like, I want the most complicated thing in the world. I want my stuff to look like the Matrix. Then yeah, don't use Sonic Pi.
Yeah. Great. Yeah, that's great, and I think it's a great time for us to wrap up now. So I'd like to once again just give a big thanks to Sam, Chris, and Stefano for giving their time. It's been an amazing meetup, and thank you to everybody that tuned in and for your interaction. It's been great to have such a wide variety of perspectives on audio programming as well, and I think that's quite exciting.